Now we're ready to talk about the electric current itself. Now the electric current is defined as the rate of flow of charge through a conductor. So let's say you have a wire here. Then you could say you have some sort of a sensor right here or a detector. And you turn on the detector and it counts how many charges pass through that sensor. By counting the total amount of charge that passes through that sensor in a given amount of time, that would be your current. We measure electric current in the unit called amperes, or for short we often call them amps. And since current is defined as the amount of charge passing through per unit time, 1 amp would be equivalent to 1 coulomb divided by 1 second. So a complete circuit is one in which you can have charges flowing through conductors all the way around from the positive terminal of a battery to the negative terminal of a battery. Now on the left figure here you have a classic situation, something you might see on a lab table, where you have a battery with wires connected to a light bulb. And on the right, you have exactly the same setup, but it's written in circuit diagrams. This symbol here is a symbol that indicates electric potential or voltage. Basically, that's your battery right there. And then you have just a simple device that's just kind of thrown in there. We'll learn a couple more symbols later on to depict the device. And then we just depict the electric current going through the loop. The electric circuit diagram on the right does not have to look exactly like the real setup, because the real setups could be quite complicated, but the diagrams help to simplify and understand what's actually going on within the circuit. Now, in order to have current actually flow, it has to have a complete path from the positive terminal to the negative terminal. You can't only touch one part of the battery, one of the terminals. So here, figure A, you have something going from the positive terminal to the light bulb, but charges cannot flow unless they can get to the negative terminal, so that doesn't work. And same story with B, you do have a complete loop, but you don't have a complete circuit because it does not pass through the negative terminal. So only the figure on the right, figure C, will work, where you have charges going from the positive terminal into the light bulb through the wire to the negative terminal. Now, here's what's physically happening. Inside of the wire, inside of the circuit, you have a bunch of charges. Positive charges are repelled by the positive terminal and pushed along in the direction. In this diagram, it would go clockwise. So positive charges are flowing this way. And then at the end, the positive charges are then attracted to the negative terminal. But on the other hand, negative charges are repelled by the negative terminal, so negative charges are flowing in the opposite direction. And then by the time they get over here, the negative charges are attracted to the positive terminal. So you have positive charges and negative charges flowing in opposite directions. By convention, we always say that the direction of the current is in the direction of the positive charges. So in this case, our current is going clockwise.